Good afternoon. Thank you for joining us this afternoon. I'm Mike Smith. I'm from Harvard University, and we're here to talk about computer science. And it's my great pleasure to be joined up here by experts in STEM education. And I won't give the introductions. You have seen their bios, but just so you know who's who here, we have Beth, and then Grant, and Colleen, and then Kamal. So I thought I would start by just presenting a little background to try and set the stage for the rest of the conversation that we're going to have today. So, two things I wanted to mention. First, in mid-February, Tom Friedman, you may have seen his New York Times opinion piece on the College Board's discovery that young people today can boost their potential for success, both in college and in life, by mastering two types of codes. First being computer science, why I'm bringing it up, but also the US Constitution. So focusing on the computer science part, the two leaders that talked about this, David Coleman, who's the president there at the College Board, and Stephanie Stanford, who's the chief of global policy, said, and I quote, "If you want to be an empowered and adaptive worker or artist or writer or scientist or teacher, and be able to shape the world around you and not just be shaped by it, you need to know how computers work and how to shape them." So that's talking about our young people today, who will be taking over in the not too distant future. But I couple this with an observation that came out of the reskilling imperative discussed in the 2018 World Economic Forum's The Future of Jobs report, which said that no less than 54% of all employees by the year 2022, which we are in 2019, that's not that far away, will require significant reskilling or upskilling, and in particular, they said that human skills such as creativity, initiative, critical thinking, persuasion, and negotiation will become even more important in the future. But for the purposes of this panel, they went and said a sharp spike will occur in the importance of technology competency. And by that, the authors meant technology design and programming. So teaching computer science is going to become much more important into our future. We talked about a very broad range of individuals there, from our youngest children through those of us who are in the workforce today. That is one definition of all, but is it the right definition of all? And how are we going to go about teaching computer science to this vastly different audience? What does that look like in the future? So I'd like to start that as the opening question that we will give to our panel here, and perhaps Grant, you would like to say a few words to get us started.
Sure. Thank you. That's a great introduction. You know, for a long time, computer science education was viewed as something that was just for the gifted and just for, people who were dedicated.
Like Grant.
Yeah, who looked like me in general, but were smarter. And, and in addition to that, the whole approach to computer science education was pretty masochistic. It was, if you didn't suffer, then it wasn't real learning. And the problem with that idea is that it excludes way too many people. And we got kind of caught up in this idea that learning and struggle were the same. But we don't teach many other subjects like that, right? And so in a world where by 2030 we're going to have 100 billion connected devices on the planet, so software will literally be everywhere, collecting data and listening to you, kids need to understand what's happening in the world around them. And it turns out that if we change our approach, we can let kids engage in computational thinking and create things. So there's platforms like Scratch, which is out of MIT, that has been around for 13, 14 years. Kids are making about 1 million projects a day on that platform. Those kids are generally between the ages of like 9 and 13. On our platform, they're making 27,000 a day, which is kids ages 4 to 10. So we have a platform with a no words interface. And so part of what we have to do in order to allow more people to have access is change how people interact with computers. And that's happening in unexpected ways with things like Alexa, and then it's happening in planned ways with tools like CodeSpark Academy. So kids are going to interface with technology, and the question is, how thoughtful are we going to be about it, and what questions are we going to encourage them to ask as they interact? I can go on, but the other thing is we have to be really thoughtful about how we reach traditionally marginalized groups in computer science, so specifically women and minorities in the U.S. Usually poor schools have not had access to computer science education, and part of the problem is teacher training. So how do you have enough teachers who can teach this subject in a way that's meaningful? Well, by making tools that are self-directed, you overcome the need for teacher training. So yeah, I'm going to stop there. There's lots of things to talk about, and Colleen will rebut me.
Just on a few things, but not like a lot, and in a very loving way. Okay, so I want to pull apart the last piece around students who are marginalized in computing, and I think that's a helpful term. But I want to pull apart, so often that's women, they're not getting encouraged, they're getting pushed out, etc., women of all races. And then we see that for Black, Latinx, and Native students as well. And often they're referred to as minorities, but I think in the US, and certainly in the globe, they're not minorities. And so I think, I think we can push past using the term minority, but then jumping to the poor performing schools, I think it's important that we make explicit times where we're assuming that Black and brown kids are attending poor performing schools, and not assume that every Black and brown person attends a poor performing school. Because I find that in computing, we often will treat someone's demographic variable as explanatory for their performance. So at Berkeley, we had a narrative that women were just less good in that second class, that data structures class. We didn't know why. But if you just control for a particular programming language and whether or not they had seen it before they took that class, there was no gender difference. And so their gender was not an explanatory variable in that model of performance, and I think we should think about someone's race by itself as not the explanatory variable. The explanatory variable is racism, or do you know what I mean? Like, it's these other pieces, yeah. And if we assume that every Black and brown student attends an underperforming school, then an underperforming school is a mechanism by which we might expect less of them and all that jazz. And that we can't conflate those two because it's real problematic. That's what I think. Yeah. Grant doesn't disagree.
No. In fact,
do you know what I mean?
we offer our solution for free to public schools to avoid that altogether. And 50% of our users are girls.
Yeah.
So,
and I'll take off from where Colleen was leaving there, which is, we have to write grants and things around words like minority and underrepresented students, but really the reason I care about CS for All in K-12 is that our problem is when students come into the university, and even if they decide up front they're going to major in computer science, we put them basically in the same course, no matter how much experience they've had. There's slight variations on that, but really, especially UCSC, unless you got a 4 or a 5 on APCSA, you're going to start in the same course with people who've literally never seen a line of code in their life. And we say, don't worry, this is the course for people with no prior experience. Baloney, okay? That is just not true. And as a faculty member, you respond to the feedback you get from people in the classroom and things like that, and we move far too fast. And so I really think that, to keep people successful, to encourage more people to try computer science and go into it in the university setting, we have to fix the fact that we don't have it as a requirement in K-12 and that we don't have commonly understood pre-algebra, algebra, et cetera, equivalents. Until we define those, what kids would be learning at each grade level in computer science, we're going to just constantly be fighting terrible battles at the university level.
So can I follow on this question, because we may be creating the same problem again. Grant is allowing a whole set of children to have access to it. They'll show up in their K through 12 classrooms. Some of them may have done work through yours or other institutions.
California
How
needs to
deal
state that we have standards. We just developed them. They came out last September. We have standards for K2, 3, 5, 6, 8, 9, 12 at various levels, and every kid, these standards will be required for learning as soon as we have the funding to train the teachers and buy computers.
If I could,
But that's when we'll fix it. Yeah.
just for some kind of historical perspective on that. So my name is Kamal Bob. I'm at Georgia Tech, but the hat that I'm using now is I was a program officer at the National Science Foundation in SISE, the Computer Information Science and Engineering Directorate, for a couple of years. And one, relative to the terminology, the way that we write the solicitations focused on particular groups of people, you just kind of said it as a statement. But there's a lot of work that goes into that, which I quite disagree with. So there's certainly the conflation between color and ability, because we use it that way. So underrepresented minorities are Black and Latinx people, and there's a whole host of adjectives that end up going together. So in some ways, it's built into the structure. The way the funding is articulated as opportunities causes that relation to be tied together in people's minds. So we've incentivized that, one. The other is that from that point of view, as you're saying with the standards, I think that there's a comparison to math that's important. So the expectation that there will be math standards for states, we've been at the math game for 100 years. So the computing part of this is relatively new. So there's still a whole host of pedagogical questions that are unanswered. What scope and sequence? When do you begin? What kind of math parallelism is necessary? All of that unanswered. But the thing that I think is relevant to this is that if a state were to mandate, like New York did, New York City at least, mandated that they have 1.1 million students, and they said everybody's going to have CS education by the end of the decade. Which teachers are going to do that? And then if you're talking about that from the state's point of view, we had a discussion about this in a panel just now, where there are a whole host of states where the public school teachers are going on strike. So if we're going to be imposing new standards on a workforce that's in distress, the outcome is going to be that those teachers that are in schools that are well-tooled, who don't feel the threat of the need to go on strike, are going to be the ones who have the wherewithal to adopt these new standards. Everybody else is going to get left behind. And I think the historical example here, and I'm not a doom and gloom person, but the way I'm framing it is doom's-like.
Good, because I was just going to ask you, how do we get out of this?
Yeah, no doubt. I got answers. So the part of it I think that's relevant, though, is that when we're trying to solve the math achievement gap problem, which we haven't by any stretch, part of it was to begin with the standards.
Right.
And then the expectation was, because we have an articulated set of standards that everybody's going to be able to achieve, and then we had a whole teacher professional development strategy associated with that. I think that the variable that we didn't address was that the stratification in the schools themselves was so profound, and we were never honest about that. So now as we're going down the road with computing education, teacher professional development as a consequence of standards, and we're still not being honest about the differentiation in the schools themselves, then I think, to your point, we can end up going down the same road that we've already been down.
Right. So do you have some solutions for us?
Well,
What
I think
kinds
yes.
of things?
So here, the scale of this thing, at the moment, I, to be honest, I am a little bit skeptical about how we find our way out of this mess. But the reasonable solution, at least for us at Tech, for example, our philosophy is that the teacher core, at least in the K-12, it exists in higher ed too. I mean, as you know, so there aren't enough faculty, and the principal tech companies are cannibalizing the faculty. So faculty who have, PhD graduates of CS degrees are going to industry; they're not going to faculty. So the university systems themselves are also struggling. Then the way that we've kind of operationalized this as Georgia Tech is to say that we can't expect that there's going to be a sufficiently kind of yoked teacher core to be able to develop these kinds of skills to produce the outcomes in learning that we would want. So what do? We expect that the teacher professional development is a good thing, but I think that the logical end of that is there aren't enough people. There are not enough teachers who are willing, able, considering doing it to fulfill the need. So therefore, there has to be some hybrid platform. And there's nothing novel about that. Like, just say, put it online. Everybody has said that for the last decade. But I do think, though, that there are reasonable questions to ask in making the assumption that individual teachers will not be the single subject matter experts. And therefore, how do we appropriately facilitate their weaknesses in the computational side and enhance their strength with the relational side, with the students themselves, the communities understanding who those kids are and what their weaknesses, frailties, strengths may all be, and then answer questions about that hybridity. And I think that's where the innovation part is going to play out.
Right.
And I also think, just lastly, and then I'll stop, is that the expectation, certainly at the at the NSF, I think one of the precepts of this idea is that computation, because it's interesting, it's engaging, like that idea is out there, which is true. But I think we're using that argument to circumvent the necessity of the math aptitude. Students need to be mathematically
Math
skills.
Yeah.
Their mathematical maturity has to be resolute in order for this to actually work. But we're skipping it as if we didn't solve the math problem. But so let's just go after computing, and then we'll figure out how to do this. Deal with math later.
Can I jump in?
Yeah.
Okay, so just a few things. First of all, why do we care?
That was the last question we're going to let you ask.
Yeah. So first of all, why does this matter? There's three reasons. One's the future of work, which gets talked about a lot, right? And that's sort of self-explanatory. Like AI and machine learning are coming, and software is going to touch everything.
It's not obvious that with more AI, more people need a program.
No, but it is obvious that you should understand how computers work, right? And then two, and this is one that doesn't get talked about enough. Computer science is a really lovely platform for self-expression that most people don't get access to today. And that doesn't get talked about enough. And it's a way to augment your own personal skills in a way that's really meaningful, right? And then the third is there's this almost human rights issue of there's going to be people who can do this and people who can't, and the people who can will probably have an advantage, right? So that's one. That's why we care. And then I think if we have a broader definition of success, like one thing I think that gets caught up is everyone on this stage but me is a real computer scientist who has been trained in computer science and thinks. Okay, well,
We got an engineer over there.
more than me. Anyway, and so I think, when I see a third grader build a game using our platform, right, and then they're so excited about this act of creation, and they're thinking about, they're engaged in computational thinking. It's not really coding, right? But they're really happy about it, and it's building confidence and interest in the subject, and it's a step forward. Or like in middle school, we have special education students who are developmentally delayed using our platform because it doesn't require reading. Those are meaningful steps forward from a base of 0, right, that matter. And I think, so we have to think about like what the ultimate goal is, and that's super important that we have standards and that we have a path towards that. But it's okay for us to get there in fits and starts as long as we make progress, right?
It depends who gets the fits and the starts.
Yes, and that's why, so one thing is we have to be mindful of the teacher shortage problem. So how do we help teachers move from a model where they're responsible for teaching the material to a model where they're teaching project-based learning and they're acting as coaches, right? Can we do that at scale? For example, I think in elementary school the answer is for sure yes. I'm not an expert in middle school or high school, so I'm not sure. But I do think there are creative ways to get there and to overcome these challenges. I mean, look, I'm an entrepreneur, so I'm an optimist, right? No one would ever start a company if they were a pessimist, because it's a terrible idea. But we are seeing meaningful progress, like in terms of the use of our platform, the use of other platforms that are similar, and we are seeing people have meaningful conversations about what success looks like. And in the last 3 years, and then I'll stop. 29 countries have adopted mandatory K through 12 computer science standards and are in different levels of implementation. 48 states have declared the intent to adopt standards. 30 have actually begun. And the 60 largest school districts have all adopted mandatory K through 12 standards. So there is a good step forward. It's just like we have to keep pushing it along.
So we've talked a lot about standards, and I want to make sure that the audience isn't left with the perception that we're gonna ask everyone to write a bubble sort or a memory allocator. Can you give a little bit of background into the kind of, at least for K through 12?
Sure.
Yeah.
So one of the things that kids should be able to do by the end of 2nd grade is that they should be able to take a complex process, like getting up and going to school every day, and they should be able to decompose it into individual steps that are smaller and simpler and be able to write that out and describe this big process as smaller steps. That's it. You know, okay, there's other things, okay, that was one out of like whatever. But that's the kind of level we're talking about. When we're talking about 5th and 6th grade, at that point they should be able to use one of these, if you've not seen block-based programming languages, instead of having to type things with parentheses and whatever, you just have these little Lego tiles, essentially, 2-dimensional Lego tiles, and you drag them onto the screen and you click them together, and you make your kitty cat or whatever your little thing is on the screen, you know, act out your route to school every day. And so you can get the key components of controlling a computer. Computers are powerful not because they do exactly what we told them to, but because they can easily repeat instructions much faster, right, than humans can. And they can choose, oh, sometimes we'll do this instruction, sometimes we'll do that instruction based on whether the person pushed the letter A or pushed the letter B. So there's this idea of the creativity very much like you can solve problems, you can create things of your own design, and while you're doing that, you're learning the basic, what we call computational thinking processes of taking a big goal, breaking it down into smaller parts, and then using the actual, like the instructions we give computers that are really, really small and dumb, not big, like, big things that you can have control over that. And I think that's actually one of the ways that we're gonna deal with the teacher issue. It's true, we can't just go out there and be like, okay, we're gonna make we're going to grab half of all the teachers out there, or even 1/10 of all the teachers out there, and we're going to bring them back to some nominal theoretical classroom and teach them computer science stuff. That's just not going to happen. But I do think is, for one of the reasons I think probably many of us went into computing, what's great about teachers learning on the job computer science while they're doing it is computers are there. You can learn from them, right? I loved computer science in high school because not that we had a class, I had to do it as an independent study, but in math, I had to wait for the teacher to teach me, theoretically, or read the textbook, but I wasn't good enough to learn it from the textbook. With computer science, like you're trying to write a program, the computer gives you feedback. It's like, oh, that didn't work. Oh, let me try changing something. That didn't get work. And so you can kind of continue to develop your understanding and growth as an understanding about computing as you're doing it. And I think teachers are in a way in a great position to do that if we can help them understand and scaffold them in doing that. But that while they're there in the room with the 4th grader, doing something, helping them solve a problem, they're actually refining and improving their own understanding of computing.
I've been going to high school computer science classrooms that have been using a curriculum that's primarily web-based, so they're on a very small screen, following instructions, managing tabs between a programming environment and that. And the teachers are great, they have great relationships, but they don't seem to like it. Do you know what I mean? And it's like, you walk in the classroom and you're like, meh. Do you know what I mean? And I think it's interesting to think about, just 2 weeks ago, I was also in a math classroom, and in that math classroom, kids were at whiteboards, and they were in groups, and they were working on exponentiation, and the teacher was looping around, and their thought processes were visible, and it was easy to tell who was not engaged, and the teacher quickly intervened. It was easy to see who was stuck, and the teacher quickly intervened, and I think we have none of that transparency and convenience, even in classrooms that have the setup. So a common thing is that kids have all the computers, and then a teacher can see all of their computers, on their computer. Even in that scenario, I still think, kids doing an online curriculum in a high school classroom, I'm kind of like, meh. If you have Beth's motivation and superhero-ness, sure, yeah, it's gonna go great maybe, but maybe Beth is an outlier, and we're not there yet in terms of making this a pedagogy that I would expect any kid to want to opt into.
What do you think? Some of these companies now are trying to bring their own, the TEALS program. Microsoft has a TEALS program where they bring their own Microsoft folks into schools as volunteers. A lot of other companies are trying to follow suit and do similar kinds of things. The teacher critique of that, of course, is that those folks don't know pedagogy, they just know the subject. But what you're outlining is, to me, the heart of the matter, that the subject it has these parameters around it, one of which is how do you teach it appropriately and to the various ages of people. And I think there, too, we have to be very honest about the range of students' abilities, because, like I said, the math is a big, big problem. Let me just give you an example of that. So this math thing, I just want to, the
Like
I
thing
was
that
about
really,
to interrupt him or something.
no. This math thing is really bothering me. So my daughter goes to, I live in Atlanta, and the school that she goes to is one of the very few in the district that has, it's integrated. It's crazy to have to say that in America these days, but nevertheless, it has a fair number of white students, black students, etc. And what happens is that the math, notwithstanding the potential of a stereotype threat here, but the math differentiation between those who are kind of excellent learners, I think is the way they call it, versus those who are developmental, those are the poorest learners. So the two charts, if you look at where the white kids are versus the black kids, they just go like that. So the preponderance of white students are advanced math learners, and the preponderance of black students are these developmental learners. On top of that, she has said that the instruction, one body of students versus the other, is almost profoundly different. They see it, the kids themselves know it. So now we're saying that we're coming in to figure out a way to introduce computing, let's say. And I've done this on behalf of Georgia Tech at this very school. And what they'll say is that the best place to do it is in the International Baccalaureate program, because those are the teachers that have the wherewithal to be flexible enough to do the superhero type of things that Beth is capable of. And then the other thing is that if you go into the CTAE, which is a career technical educational, that's kind of the VOTEC for those of you who are my age. So if you go over there, they're saying, well, these teachers, they're kind of good at making sure the students behave themselves, but you're trying to ask them to do advanced stuff. And I'm not throwing indictments out, I'm just repeating what was said to me. And they won't be able to kind of do the things that you're asking them to do cognitively on top of managing the students in those courses. So to me, the point that you just raised is if we're going to have a challenge that's laid out without being forthright about those differences, then ultimately what we're going after is the utility of standards and looking at the way that we can teach these things innovatively with the students who are most able to be innovative themselves, because they're set into a structure that facilitates that. But everybody else is just kind of in this rigid thing to get you out of developmental learning into the next thing. And I think that we have to frame the problem that way, say we're not telling the truth.
Framing matters tremendously here. So I don't want to spend all of our time on K through 12. We mentioned a little bit about the challenges also for higher education. It sounds to me a little bit like we were talking about, you'll be taught computer science in one classroom, you'll be taught math in another classroom, in science when you talk about K through 12. That's one of the things that's actually up for debate right now in higher education, where the computational skills are being recognized by many of the different disciplines within higher education. And now there's a little bit of a ground war going on. Who's teaching it? Is it all going to be done by the computer scientists? Is it going to be done by the individual departments and so forth? Do you have thoughts on where that's going to play out?
I think that's a Beth question,
Yeah,
too.
so maybe at the administrator level, people who believe there's a ground war, straight up computer science professors are like, not me. I don't want to teach non-majors. You know, and moreover,
It varies by institution.
only
Fight over
slightly, but it's partially also because we have the numbers are out the wazoo. So you know, maybe 10 years ago, if somebody in my position, I'm a teaching professor, so I do more teaching than other people. I might teach, I don't know, 500 students in a year. Now let's try, 500 a quarter. This is 2 classes of 250. That's what I'll be doing. And so it's not surprising that, when there's just, your classes just keep getting bigger and bigger and whatnot, that the faculty are just going, stop. And if you understand the whole thing of higher education, how we hire people for life, we can't just hire more faculty, even if they weren't going off to Google or wherever. So really, most of them don't want to do it. Secondly, you all, or as taxpayers, at least for public institutions, you shouldn't want computer science faculty to do it because we don't know how to teach. We talked about the math thing. We've been trying. How long have we been trying to learn how to teach math? Well, like literally about 1,000 years, probably. So people have been like, oh, that didn't really work terribly well, and they've been working on it. We still have a problem with it, at least within the context of formalized education. But we've really only started to think about how to teach people computing at best from the early 70s. And we really don't know a lot about it because of the way, it's always been the struggle, you said. It's like, well, I learned it myself in the basement with a computer, so if you can't do it that way, you don't deserve to be in computing. And that's just completely wrong. There is this ability that you can grow your intelligence and things like that. But most computer science faculty don't know about that. So certainly what is happening at
And don't believe when you tell them.
Oh, I know. Oh, don't get us started. But you're going to start seeing computational social sciences majors. We got one of those. We now have a data science major. We're going to have the biological sciences division is going to define a computing course that is necessary for their students. Now, is that necessarily the better way to go? There's challenges on that side too, because they're probably not going to have people who are expert. There are some experts in how to teach computing around here. They're probably not going to be able to bring those people in to do that. The question is, will they at least talk with them and or consult with them on the development of those? But I do think there's many institutions you're looking at. There's so much demand that it's going out to each of the individual departments. But that's going to be also a challenging thing. We need to all stay connected in some way, and that universities are not very good about that.
I mean, I think it's super clear that coding and computer science are going to be linked to every discipline, and you're going to use computers to solve problems and build models and do the things you need to do because that makes the most sense for that particular problem, and we're going to get there sooner rather than later, and universities will adapt or die on this point. At Princeton now, the most popular first year class is Introduction to Computer Science. 70% of all incoming freshmen take it. And that's just one institution that's having this massive sea change. And there, I think, will always, of course, be paths that are just about computer science, right? And you will become a machine learning expert or whatever your path is. But more and more, it's going to be seen as abnormal not to use computer science to, analyze the words that Shakespeare used in all his plays, or to figure out how to build a small model of a population for biology, right? And the decay of, different biological organisms. So that is coming, and whether people like it or not, and the question is, how do we get on board with that, and how quickly do we adapt? And, universities are under pressure from a lot of angles, and this is just one of them, but it's gonna happen.
Colleen,
Yeah,
Harvey Mudd's done a lot, and then I know Georgia Tech has too, if you do want to say something about that. So, but Colleen first.
Yeah, certainly we're seeing this flood, and I think it's a real crisis at colleges where, we're hiring in computer science. Since I joined 7 years ago, we've almost doubled our faculty in the department, and that comes at the cost of other majors that are not able to replenish their faculty. And I think, yeah, and a lot of our messaging, even around like, say, STEM or STEAM, is like, oh, no one needs history or politics or sociology or anthropology, or like, how are people going to know how the world works if we're cutting them out of this acronym, and if we're cutting and closing their departments? I'm not like so convinced that everyone's going to be programming. I do think like if you're going to be a physicist or a chemist, like for sure you're going to be programming a ton. But then like I bet a bunch of other people are going to be using Excel a ton. And if you were like, Colleen, everybody should learn Excel, and I'm like, oh, I bet that's probably true. And there's programming in there.
I just want to throw the policy side again, just because of the NSF stuff. The National Academy of Sciences had a report recently, as you probably know, about the burgeoning enrollments. CRA also had one with Tracy Camp. So the university capacity is really tapped out at the moment. There isn't ability to engage all the students who are interested. And so one of the things that, just to lay out again some of the parameters of what the for all part means, is that as a practical matter, the instinctive reaction of institutions is to limit the access to those majors. And I don't think it's insidious, it's just that there aren't enough faculty, so like we have to just raise the barrier to entry such that we can accommodate this course in the spring. And what that ends up doing, to your point, Beth, is that it ratchets out, it filters out the students who don't have any preparatory access to the courses. So one of the consequences of this enrollment problem is that. And so Tech, for example, is trying to figure out ways. We have this whole thing called the Next Generation University. And part of it, I think, which I really buy into, is trying to reassess what a public institution is supposed to do. And we're supposed to serve the public, not just the elites. So therefore, if we're trying to lower the barriers to entry, at least to particular kinds of courses that we perceive the public finds interesting, we've put some parameters around that problem too. So one, we have the online Masters in Computer Sciences, you probably know, and it's kind of a broad web-based way to get a master's degree at Tech, but when you get it, there's no asterisk that says you got it online. It's just a master's degree, computer science, Georgia Tech, that's it. And it's at cost, so it's only $6,500 relative to if you came on campus, you're paying 40-something and some change. So one is that. The other is that in the undergraduate space, because there's so many students who have to take, we mandate that everybody takes CS1. And there aren't enough faculty to do it. So one of the things that we're experimenting is to just put that online. For those students who have the aptitude to do it on their own, we give them the choice to do it. And that helps kind of accommodate those learners who just want to be able to figure it out on their own. And I think there too, with other universities that we're now consulting with who don't have the wherewithal to do it, we're trying to figure out ways that we can partner with them. So again, we're just trying to reconceive what it means to be a public institution, not just in service of the students that are coming to Tech, but in service of other institutions around the state that don't have the faculty that we're trying to engage.
Well, and let me just take the opportunity to take that like another step further. We've had this entire discussion around CS for all in the United States. We're not all. And as our birth rates go down and then birth rates go up in other places or stay the same, in 20 years from now, we're going to be way less than all. And if we do think, as I think many of us do, that computation is going to have a very powerful role in human development, in finding, solving the really, really challenging interdisciplinary problems that as humanity we're going to need to solve. I mean, let's just put climate change out there. But we can't afford to throw away the all that are not in the borders of the United States. And to that extent, how can we, what is our role as US institutions, but also what is our role as computer science educators to try to, influence how computing is taught, around the world, and to make a much greater number of people interested in it and then potentially successful at it, so that we have enough brains out there working on the hard problems and knowing how to potentially use computers to address them.
And just to add to what was being said here too, it's not just a lack of faculty in this whole thing, but even a lack of classroom. When you've got a class that is 1,200 people, what do you put in? There's lots of pieces of this. So we only have a couple minutes left here. I want to ask two more questions if we could, fairly quickly.
10 seconds each, go.
10 seconds each. First of all, there's a lot of, and I was supposed to ask who's sitting here so we had a better idea of who we were speaking with, but I forgot, I apologize. But there are certainly people here who are trying to build ed tech for many of the situations we've been talking about. And I know one of the struggles that we talked about when we got together earlier was students and teachers being overwhelmed by lots of different aspects of there's this product, there's that product, what do I use, and so forth. A couple of words on that just to help with the audience perception in that space would be tremendously helpful. If anybody wants to take it.
I think just because you can convince a teacher that it's cool, it doesn't mean it's going to be good for kids and their learning.
Yeah, I would just say look for products that have efficacy data, right?
100%.
And most don't, and so that'll quickly narrow the field. And if you're not sure, contact the creators if you're interested in it, and usually they can tell you right away if they have efficacy data or not. So that's a good filter to start with.
Okay. And then for the last question before we all adjourn here, I hope you've taken away from this. This is a multi-dimensional problem. There's many different aspects to it that all need to be considered in order for success to occur in these different venues that we've been speaking about. I'm sure there is some generous soul in the audience that might be thinking, hey, I have some resources that might be able to be used for this. And I wanted to give our panelists here an opportunity to say, if someone said to you, I have some resources, particularly if I had some money, what would you do with it? What would be the biggest change that you would make today to help us continue to move forward here? What would it take for you to be able to do that? And tell us a little bit about why. So if we could just touch on it. Kamali, would you like to start?
Well, the smaller scale answer is I think that the investment in what a hybrid infrastructure looks like needs its own set of investment. That needs, several questions need to be answered about how to do that best, what that scope and sequence, all the things that I was mentioning before. I think that's kind of a programmatic level. But I think the larger thing, if we're talking huge investments, is I think that the industries that are focusing and pushing this argument need to be corralled in a way such that they can influence the production of people at the university level. The state governments can't do it alone. And that can be translated from higher ed to K-12, depending. But I think the complementarity of what the industries are doing, particularly in the higher ed space, because they're cannibalizing the faculty. So they are responsible parties in this ecosystem, and I think they're pushing the boundaries of that problem to be innovative. That would be a place.
Terrific.
I would say there's a lot of excitement about computing and all that jazz. Please donate to just like the regular education stuff. Do you know what's more important than computing right now? Reading. Do you know what I mean? Like, just donate money to people who are trying to help kids learn to read, because that's really important, and it's not exciting or sexy in like this context.
Great. So I'm going to say something slightly off that topic, which is just, I don't think CS for All needs to be a binary conversation. It drives me a little bit crazy when it's framed as it is. Like, we can either teach kids about computational thinking, or we can teach them about history and civics. Like, no, all the things. Like, that is our job as educators, is to teach the things that kids need to be successful in life. And of course we can't give up reading and math and basic skills, but we do have to rethink about, moving from a knowledge-based education system to a problem-solving based education system, and what that means, and like how much math do you need, right? I have not ever in my life used calculus, right?
Me neither.
And now I have a device in my pocket that can do it for me. So we have to be thoughtful about where the basic level of necessity is, and how we expand out from that. But it's not binary. We can do both.
I disagree.
I will start from Kamal's point that just because we create standards and nominally train teachers to teach something does not necessarily mean we're going to close our very important gaps that we need to close. But I really do think that K-12 teacher preparation and novel, crazy new ways of doing that is the most important place that people could make a big bang for their buck right now. And in fact, if you would like to train a teacher to at least meet the minimum requirements to teach computer science in the state of California, I can do it for you for $2,600 a teacher. They don't have to come to campus. It's a MOOC to accredited campus program. We have to look at novel ways to engage teachers and to do some studies to understand what is most effective. But it doesn't have to be, we can't just wait and fill the pipeline from the 20-year-olds coming out of undergrad to go into the classrooms.
Great. Well, thank you. Please join me in thanking our